Hi there, everybody. Welcome to our learning lab about AI images and libraries. I'm really excited to have you here today. Well, we other a lot to talk about today because this is secure AI containers is a big thing. So I'm really excited to introduce my esteemed colleague, Patrick Smyth, who's a principal DevRel engineer here at Chainguard. He's going to be talking to us today about using AI container images in a more secure way, which we're really excited about. We don't want to just be all Wild West about AI. I know it's tempting to be a cowboy, but sometimes you gotta take a step back and do things more secure and more the right way. And the other thing we're really excited to talk about is Chainguard Libraries, which is where we have some new cool things to share about that. So I will hand it over to you, Patrick. Do you want to share your screen?
Yeah, and we've got
Hello, India.
cool. We've got
Awesome.
two demos
We
for you
look good.
today. Awesome. I'm glad we can see things. All right. So my name is Patrick Smyth. I'm a principal developer relations engineer at Chainguard. I'm live in Queens, New York. I grew up here. I still live here, so I didn't get too far in life. And I, when I'm not, vibe coding or hanging out in the sauna, I like hanging out with my wife and little daughter. You can reach me. I'll share my LinkedIn and stuff at the end. But let's get ready a little bit. We're gonna actually do two demos today. But in order to prepare yourself for the first one, it might make sense to pull the image now because then you'll have it ready to run the demo later. So go ahead and pull or run this Docker pull command to pull this down cgr.dev/chainguard/PyTorch, and that will pull our secure minimal PyTorch container image. For the demos, I'll hope you can come through together with me, and for that you're going to need Bash or some equivalent, curl. You'll need tar in order to untar something, and I think that'll pretty much and Docker, and that'll get you through it. We'll also, I'll have a little resource for you so you can run through it yourself if you don't have all of that. And the libraries one, which I think is a pretty cool little example, and I'm really excited about our libraries for AI now. That probably we won't be able to run through it together, but hopefully we'll be able to share some resources on that later. So, who's Chainguard? Where are you? What's happening? Who am I? And who are these people? Chainguard is the safe source for open source. We are all about not just shifting left, starting left. I'll get into what that means a little bit shortly. But we take that very seriously. It's not just a tagline; it really means something. And part of our mission is just beyond our products, which are like our secure containers, Chainguard containers, and libraries. Then we're also, when we work with our customers, when we work with the community, we're all about raising the waterline. And we come out of a lot of like security and open source DNA. So our founders have been instrumental in creating projects such as SigStore, Salsa, SLSA, supply chain levels for software artifacts, Kubernetes, and others. So Google distro list. So now let's just kind of jump right into it. We're start at the beginning, but I know some of you are like, CVEs are my biggest problem. I think about CVEs every day. I think about CVEs when I go to bed, and I think about CVEs when I wake up in the morning, and I have CVEs in my sandwich. Some of you are like, CVEs is an acronym, and it has 3 letters. So none of us are born knowing what CVEs are, and I certainly wasn't. So what are CVEs? They're common vulnerabilities and exposures. They're basically known vulnerabilities in software. They're actually tracked in a big database that is maintained by NIST, and there's a whole ecosystem that's built around detecting these known vulnerabilities in software in sort of a formalized way so that they can be remediated, protected against, and so on. It's Space Jam with the Monstars and Michael Jordan. So Michael Jordan's protecting us from the known vulnerabilities. So why do you want to get rid of known vulnerabilities? I mean, obviously to make your software more secure, but because of how CVEs work, remember, like, the bad guys can also go look up CVEs in the database, and the bad guys can also use scanners on your software and so on. So once a vulnerability is known, it makes a special sense to remediate it or to remove it from your software from and yeah. So this is the little girl in the burning building. So your app really needs to be you need to put out the fire of having CVEs in it. But it goes a little beyond that because CVEs are also, if you work with certain compliance frameworks or authorization to operate programs such as FedRAMP, then in those cases, you want to sell to the federal government, or it also applies to Canada, and Europe is starting to have equivalents, or they have equivalents now. Then you need to usually remediate your CVEs within a certain period of time. Okay, which can be very difficult. Why? Basically, because I call this problem the boss assigned me to fix Ubuntu problem. The problem is that most of CVEs, when you scan your software, it's not going to be in your in the software that you wrote yourself. That's about 2% of the code in your stack. Let's just say could be 3%, could be 1%, and 98% of the code in your stack that you're scanning against, that you're looking up CVEs, that comes from elsewhere, comes from upstream, it's open source. And can you just not use open source? Obviously not. We all need to build on open source now. We don't want to slow down. We want to take advantage of the full ecosystem. But how do people usually fix this? Well, it is this boss assigned me to fix Ubuntu problem. It's that people basically are like, okay, I'll take out a spreadsheet, I'll scan my software, I make a big spreadsheet of like the literally hundreds, thousands, more realistically thousands of known vulnerabilities that are in my software, and I'm just going to go burn down that list. But however, then you have to go fix not stuff in the language runtime, stuff in the application layer, stuff in the OS. Okay, how do you do that? Well, it's very difficult. Okay, in some cases, it's almost kind of impossible. How does Chainguard do it? So Chainguard, when I joined Chainguard, which is kind of a little while ago, I guess, in startup time, a really long time ago, I was kind of like, everyone was saying 0 CVEs. And to me, that sounded like it's marketing. Like, how do they actually have 0 CVEs? Maybe they got to 0 CVEs on the container like once, and they just like to talk about that. And when I got there, I was very surprised to learn, actually, Chainguard does get to 0. And for any given one of our containers on any given day, there's a very strong chance that container has 0 CVEs. I was just looking at the Python one today. That just happened to be 0. Okay. Last time I did the learning lab, I think it was like a couple of medium ones or something like that. Okay. So it's not all the time, but yeah, we basically are low to 0 CVE containers. How do we do that? So there's a couple of ways. There's a short answer. I call it the 4-letter answer. Okay. Because nobody likes work. That's one 4-letter word, right? Toil is another 4-letter word. This is the really short answer to how we do it. It's just a lot of really hard work, and there's no actual just like magic to it or like a trick. Sometimes people are like, are you just sweeping stuff under the rug? No. I see the work that goes on, and it's real work and difficult. And we actually have a blog series that we've been coming out with called "This Shit Is Hard," which is good to check out in this area. But just beyond saying it's hard work, just to get into a little bit of our philosophy and our nitty gritty. So these are some of the pillars. Maybe not so much the thing over here, but I'll get to him in a second. Basically, we want to first be minimal, because if you actually want to get to 0, then every package times time equals CVEs. And if you're actually going to remediate all of them, then those are liabilities. So we try to be as minimal as possible. Okay. We do a couple of different things. We kind of have a distroless hardened philosophy where we actually for our runtime containers, we actually take out shells and so on. We keep things fresh, so build every day. If there's a change in the container, which there usually is, I'll talk about the factory very briefly in a minute. But basically, our images are constantly being rebuilt. I'll talk about the factory now. The factory basically is our modern infrastructure for tracking upstream, rebuilding constantly. And anytime a maintainer does a commit on any of these upstream projects that we track, I think it's something like 4,000 now, just short shy of 4,000 projects that we track in the factory. The second that commit hits, it begins a rebuild process of that project and then everything that depends on that project also gets rebuilt. So we just burning, we're constantly running the factory, rebuilding everything, and smoke is coming out of the smokestack and everything like that. But to keep things fresh and keep things secure. And then something we also are very heavy into that I think I don't hear enough being talked about, but it's key, is advisories. And this is also hard work because we have to interface with all these different organizations. But basically, we have an advisories feed where we push out things, say something doesn't apply to us, it's like, oh, it's a CVE that applies to Windows, not to, Wolfie or Chainguard OS, then we can advise on that. But we keep that very up to date, and we try to have great compatibility with different scanners. We don't grade our own homework. We don't have our own scanner. We work with other people's scanners, and so the advisory feed is very important for us. And then finally, do we patch? Yes, very occasionally, very rarely. It's kind of like the food pyramid with that, eat sugar at the top or whatever. We don't generally patch because patching won't get you there. Patching is not going to get you to 0. Patching might get you to maybe 8%. So patching is not really that important part of our strategy. We will occasionally do patching if it's required situationally. So let's talk about AI. So AI is like everything I just said, except like more so, because AI frameworks. So we're talking things like PyTorch, TensorFlow, Nemo, and these frameworks are, for lack of a better word, enormous. Part of that size is size on disk. So that means they have .so files, .a files, archives, shared object files that are basically big blobs that increase the size on disk. That's true, but really, in terms of attack surface, there's also huge amounts of packages. We'll talk more. I'll show you some stats in a second, but there's a huge number of packages, huge number of executables. They're just really big. Okay, they contain a lot. And we got our Dark Souls meme here, and the AI containers guy is kind of scaring the regular containers. So let's pick on one image just to talk. And I could have talked about TensorFlow. PyTorch is maybe our most popular AI container, Chainguard. PyTorch is, I would say, you can always argue, but like I would say maybe it's the most popular AI framework right now, a deep learning framework. And so let's just pick on it for a second and do a little comparison. So the Chainguard, basically, if you look at the number of packages, for example, Chainguard will have about 40 packages, and I think it's something compared to something like 200 with PyTorch, and we also have many fewer executables. And if you remember, I think especially, you could also say files. Sometimes people compare files. I think the best proxy for, especially in the realm of CVEs, is packages, because packages are sort of the unit that CVEs get assigned against. So if you have a package, you wait a while, eventually you'll have a CVE. Executables also maybe give you some sense of like attack surface dark matter. I don't think files give you that much sense, but we also have fewer files. And then I also have the CVEs here. And I just kind of want to quickly bring up our console. So you can pull this up, and I think Lisa might share the link in the chat. But just to take a quick look at our console, so you can look at our comparison in our console. And so any of our containers, I find the console very useful. We'll have a list of the CVEs that are currently in there, information on them, advisory stuff, a useful README. But one of the items we have is this comparison to compare to upstream. And you'll see right now, PyTorch has a lot of CVEs, but like the most important is that we have 4 criticals right now. Okay, for Chainguard, I think we have something like maybe 3 mediums or something like that. Yeah, I think you have a couple on the PyTorch image right now, very small number, and no criticals, no highs, I think. And then for PyTorch, we have, unfortunately 4 criticals and a whole lot of highs, mediums, and lows. Okay, you could see over time. This is the whole last month, and it's just mainly been hovering around a few or close to 0 for PyTorch. PyTorch is definitely hard to get down to 0. Just as another comparison, we have Python. Right now, we're at Python is 0 CVEs, and there are 4 criticals in Python as well. Okay, so and you can take a look at those comparisons. I like looking at these comparisons for different Chainguard containers just to see some of the value add there. So I kind of think we're ready for the demo now. So let's go into demo mode a little bit. We're going to do 2 demos today. So we're going, if you pull this, so it is, the link is go.chainguard.dev/AI-LL for Learning Lab. So it's go.chainguard.dev/AI-LL Learning Lab. And then that will pull up this page here. So we'll have this page where we're going to run this demo. I'm going to go into demo mode a little bit here. And we are going to train a image classification model. So let me just show you a little slide for that real quick. So we're going to look at classify between three types of image. So it's just animal classification. So it's fairly entry level machine learning application. But basically, we love our Linky, who is our little octopus mascot, who you saw at the start. So it'll distinguish between octopuses, penguins, and whales. Okay. Let's go first pull up I'm going to copy this command. So this initial command will create a folder for you called image classification. And then it will pop up. I'll start running it because it will take a while. Probably we won't be able to get through the whole one, especially if we want to go to the libraries demo, but we can kind of see the start of it here. You should just be able to paste that command as a blob in and run it. It does not require a GPU, so it should run on CPU, but that also means it takes a little while. And basically, it'll run over 25 epochs. It'll take the training, it'll download the training data. So that's something like training and validation data. So I think it's something like 40 images for each target classification. So 40 for octopus, 40 for penguin, 40 for whale, and then 20 for each for validation. So 60 for each category. And then it's going to train a little model and save it as a .pt file to this folder that's been created. And then once that's done, we can then run it in inference to classify an image. So this is going to take forever. So we've got a few epochs in. So in theory, we could wait for the end. You shouldn't cancel it. If you've started it, you should let it run to the end. But I'm going to kind of sandbag here. And just because we don't have all the time in the world to train models, then I'm going to remove. I love running RM RF commands live. So let's try not to delete my entire hard drive. Yeah, we got it up. I'm going to delete the one I just created, and I'm going to replace it with one that we all right. So basically, that skips to the end of the training because I've already trained the model here. And now I'm back in the folder. So now what we're going to do is we've trained the model, or at least, I kind of skipped to the end of the training because I pre-trained it. But you'll see the .pt file. There's the model file. So once you're done, you should see this model file in the folder. And then we're going to grab this curl command to download the octopus image. I'm going to curl this, download the image, and then let's just take a look at the image just to see octopus.jpg. Here's our octopus. He's ready to be classified. So he's in the folder. And then let's finally run this inference command, okay, which basically runs the same script, but now it runs it in inference. And it's going to take a second. Oh, and there we go. It classified it. So octopus. So basically what we've done is we've trained a model, we've saved it to a file, we downloaded a test image, we put it in the folder, and then we ran a script that points at that image as an input, and it classifies it. Now you can also pull a penguin or a whale from the internet or a different octopus and see how it does classifying it. I tested it a little bit. It seems to work pretty well. It doesn't work too well on like cartoon images, though better than random or whatever, because all the images in the data set are realistic. So just FYI, if you're playing around with it. So now I do want to do another demo because we are, that's our containers, secure containers. use our secure containers, reduce your attack surface, reduce your CVEs. I'm really impressed with them. Try them out. They're, the PyTorch image is public. You can play around with it. But we have something actually very cool and new to show you guys, and that is our Chainguard libraries. So we have the three ecosystems for Chainguard libraries. It's Chainguard libraries for JavaScript, Chainguard libraries for Java, and Chainguard libraries for Python. And now within Chainguard libraries for Python, we have Chainguard libraries for AI applications. So I'm going to briefly show you a LSTM model running on our PyTorch library, not even within a container. We're just going to create a virtual environment. I'm going to show you installing from Chainguard libraries directly from our package index. And then we're going to run our little verification tool so you can see, okay, what comes from Chainguard, what comes from I'm going to say upstream, but what I mean is PyPI, the public package index. And then we're going to run our little LSTM, long short-term memory text completion, okay? So let's go back into demo mode. Now, I just do want to briefly explain what libraries is, or what I'm even talking about. And what libraries is basically we take ecosystems. So in our case, so far we have Python, Java, and JavaScript. We look at the public index. We find the source, the link to the source. We find the actual source. We ingest that into the Chainguard factory, and we rebuild every package ourselves and put it on our own secure index. And why is that helpful? Basically, it protects you from supply chain attacks, which are on the rise. Okay, so we're talking supply chain attacks like Ultralytics, which happened in December 2024. We're talking about supply chain attacks like PyTorch had a dependency confusion attack in 2023. We're talking about Shai-Hulud. This is what you'll be protected against, and I would say year over year, this has doubled in the last year. So this is, as you know, probably from hearing about Shai-Hulud in the JavaScript ecosystem, this is kind of a big deal right now. And this is what Chainguard Libraries is going to protect you against. So let's go back into demo mode, and gonna go back to my home folder, go to my project folder. So I have a little script. Let me make sure. Yep. Okay. So I have a little script that is the LSTM, which is what we're going to run, which is why we're going to this folder. You can take a little look at what I have here. Basically, what I have is a virtual environment. We're kind of have to do the same thing because it takes quite a while to install PyTorch. But I'm going to start the installation so you see everything works. And then I'm going to replace it with a virtual environment in a minute. So let's start by going, and I'm going to replace the pip.conf. So let's go to our tilde/.pip folder. And basically pip.conf you can change, oh, I want to pull from here, I want to pull from there. So instead of pulling by default from PyPI, the public package index, we're going to pull from Chainguard libraries, and we're going to install based on that, okay? So I'm going to copy this config I already have set up for our CUDA repository, our CUDA-enabled packages repository I have, and we're going to call it pip.conf. So basically, this means that what I've done is I've changed pip to install. Instead of installing from PyPI, it's going to install from Chainguard libraries, our Chainguard library package repository, or Chainguard libraries index. Okay, going back into our folder with the script. Now I'm going to create a virtual environment. Just calling it venv, Python -m venv. So now I have a virtual environment. You can see it here. I'm going to activate it. Source venv bin activate. Okay, now I can install to this. Now, before I install anything, I'm going to run our chain-ctl is our tool that we use at Chainguard for a whole bunch of different things. But one of the utilities we have now is to verify whether a library or libraries within a virtual environment have come from Chainguard or from elsewhere. So I'm going to run it on this venv. It should basically be like 0%, because we haven't actually updated or pulled anything. The only thing in this venv right now is basically pip. chainctl libraries verify then. Okay. And it would normally have to log in. I logged in earlier, so it basically says it's 0%. Now I'm going to force reinstall pip. So you can see pip install force reinstall. I think that's a hyphen, and then pip. Okay, we're reinstalling pip from Chainguard Libraries. So it's our secure library from our secure index. And now we're going to rerun that chainctl verify command. And now it says 100% because I've replaced pip in this. So we don't have it installed CUDA. We haven't installed, CUDA torch, any of this stuff, NumPy that we need for this script. But I'm going to go ahead and run the installation now. But because it's going to take so long, I'll probably cancel it. But let's get it started out. Pip install. And what's needed for this is torch, which we have now built on our Chainguard Libraries index, and NumPy. Okay. And I have to say, like, hats off to our engineers, because these are not easy packages to work with and build, and it seems to kind of work surprisingly well. So good on them, and amazing. I'm very excited about this. So it will take an extremely long time to install. So I have the vent set up now to copy out. So I'm going to remove the one I created, then goodbye, and then I'm going to move the venv I have prepared to be called venv. So just a little demo, shortcut here. And then, so now I'm going to run chainctl verify on the venv again. And you're going to see a lower number than you might expect, but I'll tell you why. So it's something like 46%. Okay. Why is that? Basically, it's because we have CUDA, proprietary CUDA upstream libraries that cannot currently be rebuilt within the Chainguard factory. So it's just, we have to just pull those from the public package repository. There's kind of not really much way around that. So it is what it is right now. But let's now go ahead. We now have everything installed. So we have everything that we could have made secured, and we have a venv now with as much as we can install from our Chainguard library secure index. And now let's go ahead and run our fun little and what is this? Basically, this is a little bit of a brag. So like, I really love our SLA, which is our software license agreement, which I think is unusual for people in a company. And if you pull up the Chainguard, let's just Google it, Chainguard SLA. Hopefully it comes up first. Yeah. All right. So Chainguard SLA, it's I always joke, it's very long. It's very long these days because they added 100 words because of libraries. But it's like something like 500 words now. It used to be like 400 words. It's very short for an SLA. It's very clear. I actually recommend pulling it up, taking a look at it. I am proud of it. It's very cool. We remediate critical CVEs within 7 days and everything else within 14 days, which is very short, industry leading, clear, understandable SLA. So I thought what would be kind of funny is if you ran a model. We need to bring our SLA in line with the rest of the industry. We're making it long and incomprehensible. So we're having AI write a long, incomprehensible SLA. So basically, it's going to use our SLA as a seed and try to continue it. So let's go ahead and run it. Got it. Source. Let's deactivate. Yeah, we have to load up the new source, then bin activate, and then run our SLA.py. Okay, so it is now basically what it's going to do is going to go through 15 epochs. It's going to train this LSTM on our SLA, and it's going to try to come up with a model that will be able to continue it. And what's kind of fun is you can see in the first epoch, it's just nonsense here. It says, Chainguard willable tenten dipsy. It just sounds like nonsense. So now wait for the next epoch. You'll see the next continuation, which is kind of fun. I love ML demos because you have to wait around so long for things to happen, but it is what it is. All right. Chainguard will second parity scoring. So now it's at least looking more like English, but it's still more nonsensical. Fun shell stick whatever. I think around 10 epochs in my testing, it started to read more like an actual SLA, slightly not semantically nonsensical, but basically following the correct format. Okay, let's see how 10 came out. Chainguard will assign excluded version streamer failure to meet the commitment. So that's starting to sound like a software license agreement a little bit. And then let's see how it does at the end. And it'll do a longer sample once the model finishes training. I could start reading Hamlet, to be or not to be, that is the question, whether it is noble in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of trouble and by opposing end them. I was going to say, and by sleep to say we end, but okay. That's enough Hamlet. All right, so we got our SLA output. In no event shall, so these are seeds. So basically we're handing the model different little seeds that I basically pulled out of our SLA, and then it continues them. Remediation will then demonstrably be added to, and then it adds some URL. So it's somewhat nonsensical, but it has the general vibe of an SLA. And then at the end, I'm slightly trollishly wrote, now your SLA is like everyone else's, not very comprehensible. So, but I have to say I'm very excited about libraries, and especially for AI, because these are hard to work with. They're large, and they're a great target for attackers in the supply chain. And in fact, PyTorch has been the victim of a supply chain attack, dependency confusion attack in 2023, based on confusion between where packages were coming from. They pulled in a bad Torch Triton. So I think that this is a great target for that for attackers, and it's a great place to start shoring up your supply chain security by using Chainguard Libraries. So very cool and very exciting. All right, so I'm going to talk to you a little bit about some upcoming events. Well, first of all, Chainguard Libraries, go take a look. You can go to chainguard.dev/libraries. Or just Google Chainguard Libraries. It's very easy to find if you're interested in reading more, finding out more. And we also have previous learning labs about Chainguard Libraries for Python and Chainguard Libraries for Java, run by Manfred Moser. And then I just want to talk to you about a couple of 3 events that are coming up that are pretty fun and exciting. So one is, trying to get the exact name here. AI-assisted migration to Chainguard Containers with the inestimable Lisa Tagliaferri, who introduced me today. And that's going to show you how to use AI to move from another provider to Chainguard. And that's on the 19th at 1 p.m. Eastern, so February 19th. And we also have, let me get the exact name here, but it is a deep dive on libraries. So library Q&A and demo. And that is going to be on the 25th, so February 25th at 1 p.m. Eastern. And then finally, very exciting, and I'll be speaking at this along with Manfred, but we also have some amazing customers, other folks from outside, talking about supply chain security, talking about AI, talking about everything. Assemble 2026, this is Chainguard's conference. It's happening on St. Patrick's Day in New York City, so the streets will be pretty interesting, and it's a fun time to be in New York. And I hope you'll consider clicking the link or taking a look at this QR code, take a screenshot on your phone wherever you're at, and take a look, see if you can make it to Assemble. I'm sure we'd be very excited to have you. All right, so I think we're basically at the end. We have Wolfie here, who's the tiniest octopus in the world. This is a real life octopus, Wolfie. He's only the size of a fingernail. He's digging a hole into the ground. And basically ask if you guys have any questions. And here's my LinkedIn QR code for you if you do want to connect. Great. And I will stop sharing my screen. Lisa, are there any questions? I'll keep this up for a little bit.
Yeah, hi folks. If you have any questions for Patrick, we do have some time, so feel free to put them in the chat.
When I would teach, I was the master of extremely long silences because if you wait long enough, someone always asks a question. So. Lisa, do you want to let someone on the mic to ask a question? Does anyone want to ask a question on the mic?
Yeah, we have one question. I'm sorry, I'm getting over a cold. So I'm looking at the multi-stage build course. Basically, we build a working container based on Wolfie, call it dev, then remove all tooling once it passes test, and it's now prod.
I might have missed the question part of it. Sorry, Lisa.
Yeah, so the multi-stage build, so you start with the dev container, which has all of this stuff in it, it will have like for Python, it will have like pip, and then you put it.
I think, do you want me to explain since your voice is a little?
Yes, I'm sorry. I'm getting over a cold and I'm just having
I was
a
like
cough.
that like 2 weeks ago, so I have the utmost sympathy. So basically, what is the multi-stage build stuff about, and like why do we recommend it? Seems to be the general vibe here. Basically, the short version is we maintain different versions um, of our containers, and one is like a hardened, minimal, sort of distroless style container that doesn't have package managers or shells. And that is what we recommend you use in production because it's the most secure. Package managers and shells are a great avenue for attack. You want to run the most minimal thing. However, that creates a problem. What's the problem? How do you how do you set up your environment? How do you install everything? How do you create your virtual environments? How do you compile your binaries if you're using Go or C or something? And that the answer to that is, well, you use our dev variant, or full variant that has everything. It has the package manager, it has shells, it has everything you usually expect, and you build whatever artifacts you need in that environment. Then in the multi-stage, and this is all in the same Docker file. This is what the multi-stage build is. The first part of the Docker file is build all that stuff, build your software artifacts, get everything ready, and then then you switch over to the runtime production, and then copy any artifacts or whatever over from the full to the minimal, and then that's what you run in prod. Is you run the minimal thing with all whatever work you needed to do dev, like just that image just gets discarded. You move the artifacts over and then you run. And it's a great paradigm because then you're running the best thing in production, and you also have the advantage of having all the tools you need to get things working. And we have great tutorials on this, by the way. If you look on Chainguard, on edu.chainguard.dev. Anything else come up, Lisa, or do you want to?
Yeah, I have a cough drop, so I'm a little better. So we have another question of how do we analyze the dev container to know what to remove? So the dev container would be the builder container for the final image. So in the case of like the free tier paradigm, it would be like the latest hyphen dev, and then that would be the builder for the latest image. So it would be, you wouldn't have to do anything, like that would be accomplished in the multi-stage Docker file. We do recommend that you pin it by digest, but the latest dev paradigm is basically what you're looking at, and that's just like the easy to remember tags for like trying it out.
Exactly. So you can think of it like a booster rocket, like the the booster gets you into space and then it gets discarded and falls to Earth. So you don't actually have to keep the dev variant around. It doesn't run in production or anything. It's just used to build whatever you need to build. And then you copy everything over and then run it. So you don't have to remove anything. There shouldn't be any reason or need for that. You just use it to build your stuff, move everything over, and then run the minimal hardened container in production. Cool. That must be a good cough drop, Lisa.
Well, I don't know. Ricola? We are not sponsored by Ricola.
All right.
But yeah, thank you so much for coming. You can try the AI containers for free today. The library stuff is still kind of early days, so it's cool that Patrick shared it, but we don't have a trial version right now. And the other thing I would say is, if you have any more questions, we do have a Chainguard community Slack channel. I don't know if I have the link handy right now, but if you search for that, it will come up. And so feel free to join us there, and we are available for any more questions you might have. Yep. Thank you, everyone.